In another video, I've explained how to use the pumping lemma for regular languages, when to use it and when not to use it. I ended the video with 2 practice questions for you to practice yourself. In this video, I'll be going through the solutions for those questions. The questions were to consider the following 2 languages, L equals a to the n cb to the power m, and L equals a to the I b to the 2I, and to prove that these 2 languages are not regular. As this video is only to check your solutions and not to explain the actual pumping lemma to you, my explanation of the answers will not be as detailed. If you haven't already watched the previous video and don't understand the pumping lemma yet, I would advise you to watch it first before you come back to this question. Have an attempt at these questions before you look at the solution on this video. Let's look at the first language then. The only condition here is that the loop n is less than the loop m. Our first step to answering this question is to assume that this language is a regular language. Next, if this is a regular language, we can assume there is an automaton for such a language, and so we can let k be the constant of the pumping lemma, k being the number of states the automaton for such a language would have. Next, we need to find a suitable word x such that the length of this word is at least k long. To do this, we need to write a word in terms of k. If we choose the word to be a to the k cb k plus 1, this word is indeed greater than k in length, and if we let n equal to k and m equal to k plus 1, n is indeed a variable less than m. Now that we have our word x, we can decompose this word into 3 subparts, u, v, and w, such that u and v is within the first k letters. Because of this, u and v have to be within the first ak's, with w being the remaining a's, c, b, k plus 1. This is the decomposition for u, v to the 1, w. If we were to pump up the v subword, we get u v squared w, which is equal to a to the I, a to the L twice, a to the k minus I plus L, which is the remaining a's, cb k plus 1. To simplify this, we can expand the brackets, giving us k minus I, k minus L. From here, we can cross out minus L and minus I with a to the L and a to the I. This leaves us with a to the k plus L cb k plus 1. And this is because we know that L of a to the L, which is the v section that we just pumped up, cannot be equal to 0. It has to have something. And if we add any number of a's, the block of a's is now greater than b k plus 1, breaking the ratio. This word cannot be part of the language because k plus L is now no longer a value that is less than k plus 1. Therefore, this pumped up word is not in the language L equals a to the n cbm. This is a contradiction, and so by the pumping lemma we have proved that this language cannot be regular. So we've completed this question. Now we can move on to the next question. Here, the language that we have to prove is not regular is L equals a to the I, b to the 2I, meaning we have to have a block of a's followed by a block of b's twice the size of it. So again, we'll begin with assuming this language is regular. Then we'll take k as the pumping lemma's constant. Using k, we have to define a word x that is long enough. The condition for this language is that I has to be a natural number, meaning I can be 0. However, if I is 0, then we have the empty word, which is not long enough. To find a word that is longer than k in length, we can say I is equal to k, which will give us the word a to the k b 2k. This word is longer than k in length. In fact, it is 3 times longer than k in length. Using this word x that we know is in the language and is long enough, we can find a decomposition of this word into 3 subparts u, v, and w, such that u, v is less than or equal to k in length, and v cannot be the empty word. So u and v will have to be within the first k alphabets, which is composed of only a's. So we can decompose x into a to the I, a to the L, a to the k minus I plus L, b 2k. Now, to construct a pumped up word, we can simply pump the v section of this decomposition of the word, and it should give us a word that is also in the language L. When we pump this word up to give u v squared w, we get a to the I, a to the L, a to the L, a to the K minus I plus L, B2K. We can cross off AI, AL with minus I plus L to give us A, K plus L, B2K. This breaks the 1 to 2 ratio, and therefore this pumped up word is not in the language L. And thus, because of this contradiction, we have shown by the pumping lemma that this language L cannot be regular. Thank you for watching. Please like and subscribe if you found this helpful. Leave a comment if you have any suggestions or requests for specific videos on topics like this.